So thanks for the introduction. My name is Balazs Bucsay, and I'm going to talk about XFLTReaT in a bit. Thanks for inviting me here. It's a pleasure to be here. This is my second time on the BruCON. I was sitting somewhere there a few years ago, but now I have this talk that I'm happy to present. So first, I would like to say a few words about me. I'm a Hungarian hacker. I live in the UK though. I work for NCC Group as a senior security consultant now, and I have some strictly technical certificates listed on the slide. I started to do CREST CCT. I passed the theory, but I had no time to finish it because of this presentation and this tool that I'm writing. I had some experience in offensive security. I started to do low-level stuff when I was 13 years old in 2000. And I had some major projects that you might know. The first one that I released was the G.I. John, which is a patch for John the Ripper. It made it distributive. That was a big thing at that time in 2009. Then 2 years ago, I started to do a research on CERTs, and I released a tool on GitHub, which is open source now. It is called CERTs. So if you want to learn about CERTs or you just want to break out CERT-rooted environments, then you can use this tool as an experiment. And this year's new research, which I started last year at Christmas, is the XFLTReaT or XFLTReaT. I already had this presentation, slightly different presentation on two other conferences, on ShakaCon on Hawaii and on the Hack in the Box GSEC in Singapore. I always try to change the slides and add new content as I develop the framework. You can find my Twitter handle as well, which is XOR-EIP. And there is a link at the bottom of the slide, which is my LinkedIn profile if you like. As I mentioned, I had some presentations around the globe, including the US, lots of different places in Europe, and one in Asia as well. I'm trying to develop this list, going to other conferences as well. So if I need to summarize my presentation, this presentation in only one word, I would say tunnels, because it's mostly about tunnels and not about exfiltration. So my first question for you, just after lunch, do you know what tunnels are? Please raise your hands if you do. Yeah, lots of people. This is a technical conference, I guess. So, have you ever used OpenVPN? Please raise your hand again. Cisco AnyConnect? Yeah, so those are VPNs, those are basically tunnels. This presentation is about a tunnel, how you can do tunneling, and it's not really about exfiltration. With this tool, you can do exfiltration, but because you are building up full tunnels, it's more like for tunneling and for VPN. If you do exfiltration with this, it will be a bit more noisy. So if you want to do red teaming and slow exfiltration, which is kind of undetectable, you probably shouldn't use this tool because it's too noisy. So for those who weren't showing a hand, I like to explain what is a VPN or a tunnel. So this figure shows you how the internet works. You have your endpoint, your laptop on the left-hand side, which is connected to a router or a modem that is connected to the internet. And you have a server on the right-hand side at the bottom, which has lots of cat videos because you like to watch them. So what you want to do, you want to connect to your server, download your cat videos, and watch them online. What you do, what is going on in the background, that if you send data and you receive data from the server, you will go through different routers, different hops. All of the hops will see your original IP address, your original destination, so the server IP address and the client IP address as well. And if your data is not encrypted, if your communication channel is not encrypted, then they can inspect the data. They will know that you are watching cat videos, right? But if you are using a VPN, then you have to set up a VPN server on your other server, and then you can create a tunnel, you can create a VPN between the 2 points. And that way, if that VPN solution is encrypted, then none of the internal hops will see what you are transferring. They will see some kind of random data, but they won't have any idea what you are downloading or uploading. The internal hops will only see that you are communicating with this endpoint. They will know your original IP and the VPN server's endpoint, but they will have no idea that you are downloading videos from that server, for example. And this server will have no idea what is your original IP because you are coming through this VPN server, so it will see only that IP address. So basically, in a nutshell, these are VPNs and tunnels. So why would you use a VPN? Mostly the reason why you use VPNs, I guess, because you don't want to go to the office, you want to work remotely, and you need to access somehow your internal resources in the company, right? So what you do, you connect to the internal VPN, and you can access all the resources, the file shares, and everything. The other stuff, when you use VPNs, or usually people use VPN because they want to hide their IP addresses. For example, they are doing BitTorrenting, for example, or they are whistleblowers, or just journalists who want to communicate anonymously. So these are different reasons. I used VPNs for different reasons. I set up mine because my ISP was filtering different ports, for example, SMTP, so I couldn't send my emails over my SMTP server. I had to connect to my OpenVPN server, so I created a tunnel, created a VPN, and that way I got unfiltered internet access. But in other ways, or with these kind of tunneling solutions, you can usually bypass captive portals and corporate proxy policies as well. Probably there are lots of other reasons why you would use VPNs, but this is just a kind of introduction. And now I have some questions for you. Have you ever used any VPN solutions that used TCP before? Please raise your hand if you did. Okay, one of you maybe could give me an example of what you used. Just shout in. SSH. Yeah, that's a good one. I wasn't thinking about that, but for example, OpenVPN and Cisco Connect can and could use TCP. What about UDP? Have you ever used any tunneling over UDP? Please raise your hands again. Maybe an example. Okay, we are not there yet. Okay, so OpenVPN can be configured. ICMP, hands please. Yeah, a few, not that many. So just a few examples, hands, ping tunnel, ICMP, TX. These are ICMP tunnels, but there are lots of others that I didn't put on the list. What about DNS? We already had the answer. It's Iodine. It's a really famous one and really good. But if you want to do HTTP Connect, you need to use a fourth one, which is Proxyfire, or you can use OpenVPN because it has a support for it. But what about pure HTTP? What about TLS version 1.2? And I'm more than sure you can't give me any example that is working over TLS version 1.2 strictly with Kerberos authentication over a proxy, for example. So I had these problems, so I started to think about this. Other thing about me, I like tunnels, that I guess you already guessed that, and I really like to travel. So I went to Morocco from Italy last year with this ferry. Actually, not this cruise. It's a really nice cruise. I took a really old and not that good ferry, which took 2 days to get there. I had a small cabin with no windows, so I was a bit bored, and I realized there is Wi-Fi in the cabin. So I started to poke around, and there was a captive portal, and it said that you can buy internet for an hour, for a day, but it was really, really expensive, and I was there for 2 days. So I started to poke around, and I realized that TCP 443 or HTTPS is unfiltered on that network. So if I have set up an OpenVPN server on port 443 TCP, then I could have unfiltered internet access for free for 2 days. But I didn't do that, so I was bored as hell. Next time, I was flying to Japan from Hungary, It was a 10-hour flight, and they had Wi-Fi on the carrier. So I started to poke around again because the internet was really expensive for an hour. I don't know how many euros, but a lot. And I realized that ICMP is unfiltered. So if I have set up an ICMP tunnel, an ICMP server on my server, then I could have unfiltered internet access, even if it's slow, for 10 hours, in the air, which is pretty cool. And this is coming back to me every time when I go to an airport. It's like a nightmare. DNS tunneling is almost always possible on airports because they don't care. So if you don't want to pay or you don't want to register yourself, you can use this solution. But I was really happy when last time I went to an airport because I already set up my DNS server, the DNS tunnel server on my server, but it didn't work. It turns out it crashed, so I wasn't that happy anymore. So at this point, I started to think about, tunneling is a really old topic, so there is nothing really new about this. But I encountered lots of problems. For example, as many protocols you want to use, that many solutions you need to install usually. So if you want to use DNS, ICMP, TCP, you need to install 3 different tools on your server. It's really hard to modify because they are using different languages, so maybe you are good at one language, but you don't know the other one. And, going and changing code in other people's code, it's not that easy, and maybe you don't want to do that. So, and most of the tools are end of life or unsupported. Even if you find a bug, you can fix it yourself, or you can send a ticket to the developer, but most of them won't care about this because it's already unsupported. They just created a proof of concept which worked for them, maybe not for you, and that's it. So I realized that the tunneling right now is a bit hard, but it doesn't have to be hard if you are using different protocols. And that point, after I compiled this list, I was starting to think about what can I do about this, and I realized that I might be able to do a better job. I'm still not sure about that, but I think I did. So this is my beast was born. This is how my beast was born, which is called XFLTReaT or XFLTReaT. It's as you wish. Before I start the stuff that matters, I would like to give you a lecture about tunneling again. So on the right-hand side, you have the Matryoshka dolls, which is a kind of, it is a Russian doll. And what you can do with this, you can put each and every one into another one. And at the end, it will be this, it will be only one. So this is what you can do with it. It's just like tunnels and MTU. So you can put one tunnel into another one, which can be placed in a third one, that can be placed in a fourth one, and so on. You can do it for a really long time, which makes completely no sense after a while. But if you do it once or twice, that makes perfect sense. For example, if you have a network where everything is filtered, you can't open your website because everything is filtered except ICMP. So you can send ping packets and you can receive ping responses over the network. So what you can do, you set up an ICMP tunnel, an ICMP server on your server, and you start the client on your client. And these tunneling solutions set up an interface on both of your boxes. And what you need to do is to capture all the packets that usually sending over the internet with that interface. That is handled by the tool that you installed. And what it will do, after capturing all the traffic that you wanted to send to the internet, it will encapsulate your original packet, which can be TCP, UDP, ICMP, whatever. It will encapsulate it, in this case, to ICMP. Because ICMP is unfiltered on that network, you can send it over the internet to your own server. And at that point, the server can decapsulate your original packet from the ICMP packet and send it to the original destination where you want it to send. When there is an answer, the server will do the same in reverse order. It gets the packet, it encapsulates it, sends it over the internet to your client. You will get this, and your tool will decapsulate the original packet, and that's how you communicate over the tunnel. This is the basics of tunneling, and this is always the same in every protocol, in every case. So what's XFLTReaT? It's not just a tool, it's a framework. It's a bit more than a tool, I guess. It's open source, Python-based, object-oriented, modular, multi-client. It handles multi-client and so on. So just to give you the feel how easy it is to use, you can go online right now and clone it from Git if you like. You need to install a few requirements from pip, and after that you edit the configuration, you just set the basic stuff that I'm going to show you, and you need to run it on both the server and client side. All the tunnels, the encryption and authentication modules the parts are modules and modular, and will be modular. It's really easy to develop for, and it's plug and play. If you copy the module into the right directory and you edit the configuration, then you can use that module. So it's a framework. Why is it a framework? Because it handles a lots of things that you don't want to handle. It used to be when you created a new tunnel, a new tunneling solution, you had to do lots of other things than just tunneling. So just like I explained, this is the stuff what we call tunneling. How you put your data into another pocket, how you get your data out of that pocket, right? When you do tunneling, you are really interested in that, and you are not interested in setting up an interface, assigning an IP to that, doing the routing table, that kind of stuff. You don't want to handle multiple clients. It should be handled by the framework and so on. And the same is true about encryption, authentication, and encoding. So if you want to develop for this framework, you just create the module that handles the data itself, how you send and how you receive data, how you encapsulate and how you decapsulate the data from the packet that you are creating or receiving. And you don't have to care about anything else, just about that, because the framework handles the rest. I think this is the coolest feature of the tool, of the framework. When you go to a network that you don't know anything about, you don't know the firewall rules, you don't know what kind of limitations you have, you just use the check functionality, and you can find it out yourself really easy. So you don't need to use Nmap or Scapy or whatever that you used before to figure out whether the ICMP is allowed or not. Just an example. With this check functionality, you can find it easily out. So what it does, it creates a challenge for every protocol that is enabled in the configuration. It sends the packet to the server, and if there is a response from the server which has the correct results for the challenge, then you know two things. First of all, there is an XFLTReaT server on the other side, and the other one is that you can create probably a tunnel over that channel because the answer came back, and that was a proper result. This is another cool stuff about the framework. So it used to be when you had to do different kind of tunnelings, like ICMP, DNS, and TCP, for example, you had to install different tools. All of these tools set up an interface, use different IP pools and different IPs. Maybe you had to do something with IP tables or with routing. Now it changed. You only have to use one interface, one IP table rule or some kind of firewall rule that you like, and that's it. How it handled is that this is the server side. So the client connects from the internet and it sends data. For example, if we stick to the ICMP again, it sends ICMP packets to the server. The server will get it and decapsulate the data from the ICMP packet. So this is the ICMP module, this purple box. When it's decapsulated, it will send it to the tunnel interface. The tunnel interface will do some readdressing. It will change the IP address, and it sends it to the kernel. The kernel will decide where to send the packet next. It will send it to the original server that you addressed from the client. And if there is an answer, it comes back to the kernel. The kernel will send it to the tunnel interface over the green line. The tunnel interface will do the readdressing again. It will change the public IP to the private IP of the VPN. And this is where the magic happens, really. because we need to handle lots of different modules in the same time. So I wrote this pocket selector module, which matches the internal IP address to the right module. So that way it will know that it has to be sent back to the ICMP module. And again, the ICMP module will wrap, will encapsulate your original packet again and send it to the internet over the yellow line back to the client. So this is how it works. In every tunnel, we have two channels. One is for data, which is WS3 for the data transfer. Everything goes over the data transfer. Data channel is just pure data that you are usually sending on the cable, on the wire. And there is the other channel, which is the control channel. You send control messages over that channel. So why do we need control messages? Because that's how you handle the rest of them, which is not data. So for example, when you send a check message, or there is a result for the check message, then you use control messages. When you need to authenticate, you use, again, the control messages and so on. Log off, if we are talking about encryption, then it will be implemented, the key exchange and everything else will be implemented with the control messages and so on. I would like to give you some examples how easy it is to develop for the tool and maybe show you about how easy it is to use. So this is the current module 3 that we have in the XFLTReaT. There are 3 modules, the generic, stateful, and stateless, that I like to call skeleton modules because the framework is object-oriented. All the modules are inheriting the properties and the methods from the parent class. You know, it's basic OOP. The generic module has everything that all the other modules are sharing, and there is a split because there are 2 kinds of protocols that we have, stateful and stateless. TCP, HTTP are stateful protocols, for example. UDMP and ICMP are stateless. Because of the difference of the properties of these protocols, I had to create 2 different trees, let's say, the stateful and stateless. So I implemented everything in the stateful class that you need for stateful tunneling, and you have everything in the stateless that is used by the stateless modules. Right now we have TCP, HTTP, SOCKS for SOCKS proxies if you want to tunnel over SOCKS proxies, HTTP connect for HTTP proxies, WebSocket, that's proxy for proxies again usually, UDP, ICMP, and in DNS. In DNS, CNAME null and private is supported, but it is really easily extendable. The TCP module is 350 lines long, and the HTTP connect is only 150, around 150. The reason, so that's the point about that's my point regarding my framework, that if you create a tunnel module like the TCP, and HTTP connect is almost the same, because what you need to do, you connect to the proxy, you initiate a connection over the proxy to your server, so you just send in the HTTP connect method, and it will build up a bidirectional stream, TCP stream over the proxy. So that's really easy to use. And because I already have the TCP where I wrote the TCP tunneling stuff, I can just reuse that in the HTTP connect. So you don't need to re-implement the same stuff again. You just reuse the code, and it's really easy to do. So that's the theory behind these kind of modules. About the ease of use and development, if you have a network where only web traffic is allowed, port 80 is allowed only, then you set up the tool on the port 80, TCP port 80. If you have a network where the ping request is not allowed for some reason, but the ping response is not filtered, then you copy the ICMP module, you just change the ICMP type 8, which is the request, to type 0, which is the reply ICMP type, and that's it. If you have an HTTP proxy that requires a special header, then you just copy the TCP, the HTTP module, and you add that one header into the request, and that's gone. That problem is gone. If you need to use HTTPS, but the proxy strictly supports TLS version 1.2, then you can just copy the TLS module in the future and set it strictly to TLS version 1.2. If you need some kind of special authentication over the HTTP proxy, then you can implement your own authentication module. You just insert that, specify in the config, and you are good to go. Oops. And if you want to go out of band tunneling, like you have 2 mobile phones and you want to use text or SMS messages just to do tunneling, you can do that as well, but it's up to you. So you just need to figure out how you connect the 2 phones to your laptop and server. You need to figure out how you do the communication between the phones and the boxes. And if you know how to send text or SMS, then you can implement your module and just send all data over text or SMS. I'm going to create a wiki for this. I'm always telling everybody this, but I had no time to even start. So my best advice for you, even if we will have the wiki, just please use the source. Just read the source sometimes, because that could help. Because you can't document everything. When I started to implement this framework, I wasn't sure my idea will be working. So even I created a few modules, I wasn't sure it will work in every case, because there are huge differences between protocols. But in the last month, after I released the tool, there is this infodocs guy who created the SCTP module on his own. He didn't have any questions, he didn't have any problems, and he created it. So I'm pretty happy about that, because it means that it can be a community tool. Even you can do whatever you want with it, and maybe you can help developing the tool and make it better to have a really usable tool in the future. If you want to do that, then please use the next version branch on Git, because that's the most up-to-date. The master is a kind of working beta, a stable beta, but the next version, what I'm using for developing the DNS and the other stuff. If you have problems that are real problems, please create issues, maybe send commits as well. And yeah, please do that if you like. In the last few weeks, I had a project at NCC. I had to test some proxies, and some of the test cases included tunneling, which I did. And I just realized maybe I can use WebSockets over the proxies to tunnel data. So I created my WebSocket module in 3-4 hours. I just put it in the framework, and it worked. So I managed to tunnel data over one of the few proxies that I use there. And now is the demo time. Just a second. So I logged in to my server, which is an Amazon server, and I have it already set up. What I need to specify is the file name, obviously. Then you don't really need to specify anything else, but I like to do that. Just to show you, so you specify it should be running in server mode, and you can set it to variables as well. I just started it, and as you can see, it runs a DNS module or port 53. The HTTP connect is not working because that port is in use. ICMP is running, SCTP is running, SOX proxy. It's basically the same as TCP, but on another port. TCP, UDP, and WebSocket. So that's about the server side. And on the client side, you have the same stuff from Git. You go to the configuration, and you need to specify really just a few things. This is the remote server IP. That's the Amazon IP that I have. I use it for tunneling, and so you need to specify your server IP, of course. Then there are some stuff that you don't really need to touch, but if you like, you can. This is the name of the interface, the server IP, netmask, and where to bind these modules. Then the same for the client side. You can set the MTU. This is the default. I don't really think that you need to really modify that, just only if you know what to do. And the authentication is only the only authentication that is supported now is the CERTs SHA-512. This is the key. And then you have the modules. As you can see, there is the TCP generic. There is different section for all modules. It is enabled. This is the server port. UDP enabled, ICMP, the SOCKS. As you can see, the SOCKS IP is a kind of fake IP. There is nothing listening on that, so it is not going to work. The same for HTTP connect. The DNS, you need to specify it should be enabled if you want to use it. The hostname, zone file, I'm going to tell you about in a bit. And if you want to specifically use a DNS server, then you should specify that. And SCTP generic and WebSocket, what we have here. So let me show you the check functionality that I was talking about. You just need to specify -- check if you want to use that. And then it is going to send different pockets, different challenges over every pocket, right? If it's green, that obviously means it is working. If it's red, there is some kind of problem. Maybe it's filtered, or in this case, there is no proxy listening on that IP, on that port. ICMP is working. SOCKS proxy is working. SCTP is not working because I'm using my phone right now, and my mobile ISP doesn't support that protocol. TCP UDP is working. WebSocket was set up on the server, but it wasn't enabled on the firewall. So if let's say you want to use some kind of module that you need to turn off all the others, that's really important. And what I want to use now is the ICMP, just to give you an example. And last one, I do a check again just to make sure it works. It seems it is working. Then you need to change the check to client, and let me start the Wireshark as well. So now it says the authentication succeed for ICMP, and it is sending some data over. So if we go here, you will see almost everything that it's ARP, but the others are ICMP. So let me open a web page, like NCC Group's web page, and you see all the data is transferred in the background. The website worked, and all the data is ICMP here. So nothing going over TCP now. Thank you. And you would think that ICMP is low, but it's not the case. It depends on your network, but I'm not sure you can see it right now, but it's scaling up and down. Right now it's 266 kilobytes per second. Let's stop this. Yeah, it went quiet. I stop the stuff, and I go back to the configuration because I want to do some other kind of tunneling. Yeah. So let's start the Wireshark again. You go to the ICMP, disable that because we don't need that anymore, and we will use DNS. So DNS is really tricky. I'm going to tell you about that again. It's a proof of concept module. It's not 100% done. It's not production grade, so don't accept anything special about this, but it is kind of working most of the times. So what's happening here? I'm going to tell you a bit. It's sending data again. So if you go to Wireshark, you see everything is going over DNS. It shows you here. So let's try to open the BruCON web page, and it works again. So you see it's DNS. And if you try to download stuff, then the speed is about 12, 15. It depends on your, your latency, your network, your DNS server, and so on. It's going up now, 50 kilobytes. Usually it's 70 for me when I test it. Yeah, let's stop before I kill the DNS server. Yeah, if you use this with your ISP's DNS server, just be really careful because the load that you are putting on the DNS server is huge. So if you really don't need to do that, then please don't do that. Okay, so let's connect again. So here, what the tool is doing is it's trying to map out the DNS server capabilities. It tries first whether row connection, no DNS is capable, possible on your server or your network, because if it is, then you should use the UDP instead of the DNS, which has a big overhead. And then it tries to map out the best encoding for the upstream and the maximum length for the upstream. It found out that base 128 is the best for upstream. Then it found out that the maximum length of the upstream is 254. Then for downstream, we can use the null type record and lots of stuff. For downstream, we can use plain text, so you don't need to encode your data, and the maximum length for downstream is 229 bytes. Okay, that was the demo part. Let me stop this before it kills my VM. Let's go back to the presentation. So because this is a technical conference, I would like to share some technical details with you. First, I tried and created the TCP, which was kind of easy because it's a stateful protocol. Because it's a stateful protocol, you have one dedicated socket for every client. You can create threads. You can do everything in threads because you have only one socket. Then I created UDP, which is a kind of different protocol because it's stateless. So on the server side, you have only one socket for all the clients. You need to select the messages, the packets for the right client if you wish. Then the next step was the ICMP, which is just the same as UDP. It's stateless, but in the same time, it's a bit different because if you are sending a ping packet, that's ICMP. It's ICMP type 8 and type 0. And those kind of messages have different fields, including the identifier and the sequence number. The identifier is a random number usually. The sequence number starts with 0. So when you send an ICMP request, then you generate an identifier which is random, and the sequence number will be 0. If there is an answer, there is a reply for that, then the identifier will be the same, and the sequence number will be the same, 0. If you send a new one, the identifier will stay the same, and the sequence number will be increased by 1. That's the basics of the ping. And because we use a lot of firewalls nowadays, and there are lots of NOT solutions, you need to track, and these solutions like firewalls and NOT solutions are tracking the packages. So you can, if you send a request, there will be one response. If there are 2 responses, then the second one will be dropped. If there was no request, then all the responses will be dropped. That means if you want to do tunneling, then you need to send more packets that you are receiving, or at least the same amount. And usually if you download stuff from the internet, your downstream is bigger than your upstream, so you need to generate your upstream, and you need to track your packets. So it's kind of tricky. It's not that hard, but it was a bit tricky. So DNS is UDP, and just like I told you, it's the same like ICMP. When you have a request, there should be a response, but you can't have responses from the DNS server when you don't have a request, because it's not working like that. So it's not 100% done yet, because the DNS is really easy to understand, really easy to implement. If you read the RFC, it's really well written and easy to understand. You can create your DNS server and relay in like 1 or 2 days because it's so easy. I'm in the basics. But if you want to use the DNS protocol for other reasons, for example, tunneling, it's kind of a pain. So different implementations use different values and different ways how they transmit data. So you need to make sure that you are handling all the stuff properly. Used to be back in the time when you did DNS tunneling, you had to have 2 different domains. One for your own reasons, for email, for your website and so on, and one dedicated for DNS tunneling. Now with this tool it kind of changes because the XFLTReaT works like a DNS server as well. So you can just use the zone file from your bind server, or you can create it by your own, and you can specify it in the configuration. In the zone file, you have the records for your domain, and when there is a request to the XFLTReaT DNS module that can be found in the zone file, it will answer for that. So if you are looking for a specific IP address for that domain name, it can answer that. If it can't be found in the zone file, then it will think that you are doing tunneling. So it will do tunneling after that. I tested my setup is basically my own bind 9 server. It is working really well with it, but it's still a proof of concept module. It supports A or C name, I'm going to tell you about in a bit. Private and null records, these are the most basic that you can use for DNS tunneling, but it is really easily extendable. You just need to implement how you put your data in that different kind of record format, and you need to add to the source code, and that's it. About the auto-tune, I already explained that to you. That was the lots of green and red lines in the screen in the demo when it tries to map out the proper length, the maximum encoding, and that kind of stuff, the best encoding. And this question is coming back to me like every time that I'm talking about DNS tunneling, that why can't we use A records, and when do I implement A records for tunneling? I won't, because it's not possible. So when you send a DNS request to the DNS server, you need to specify a domain name, and you need to specify a record type that you are looking for. If you are looking for MX record type, which has your mail server, then you will get that back. Or if there is nothing set in your for your domain name, then you won't get anything back. If you are sending an A request to the domain server, you either get back an IP address which is 4 bytes long, or a C name which is another domain name. It's a kind of redirection. So with the C name, you can tunnel stuff, because that's about 200 or 150 bytes that you can tunnel over that. But if you have an A response, that's only 4 bytes, so you can't really do anything with that. If you want to do slow exfiltration with another tool, you can do that, obviously. But if you want to do tunneling, full tunnels, you want to send everything over the tunnel, then you won't be able to do that. And the reason is that for example, the most basic TCP packet that you can just imagine, it's like the acknowledge, just for an example, which is usually 66 bytes. So if you transfer everything in 4 bytes, you need to send at least 17 DNS requests and response just for that packet. And you know, that's just, it increases it will be laggy, so you can't really do that. And even if you use IPv6 records, which is the AAAA, that's 16 bytes, so 4 times bigger, which is 4 times better, but still, it's just not enough. Yeah, and almost at the last slides. This tool can be used, I guess, for both sides, for offensive purposes and defensive purposes. So I really recommend you to use it if you like it. Let me start with the offense, because I like it more and I do it every day. With this tool, you can bypass basic and not that basic obstacles. If you know the network and you know that the DNS is all load, or ICMP is a load or whatever, then you can use those modules, obviously. If you have other kind of obstacles, for example, you have an HTTP proxy that requires special authentication, it is easier to solve your problem with this framework again. If you need a specific protocol, like I needed WebSocket, then I created the WebSocket and that's it. You can exfiltrate information, you can exfiltrate data from networks with this tool, but because it's a full stack tunnel, it will be noisy. So if you don't care about that, then you can do it. If you care about this, you should look for another tool which is just for exfiltration. And the most important for me, that I can get unfiltered internet access because I can bypass some of the captive portals on airports, on whatever. If you are working in a blue team or just the defensive side, you should use the tool again, because you can just configure it outside of your company really easily, and you can use it after you configured it properly. You can use the check functionality, and you can figure out the weaknesses of your network. So maybe you find out something that you didn't know, and that can help you. You should try to exfiltrate data, and that's really important. If it's your company, you should be the first one who is exfiltrating data from your company, because otherwise it means that you already had a breach, right? And it's better to be the first one and the last one, because, you know, that for really obvious reasons. If you have a captive portal in your company, for example, you have a guest network, then all the packets, all the inter-client communication should be dropped. The client shouldn't be able to communicate with each other. You should drop all the packets that are going externally, and you should rewrite all the DNS responses to the captive portal's IP. So whenever the client is opening a web page in the browser, the captive portal will be opened because the DNS was redirected. You can even redirect the TCP connections as well if you like. After the guest authenticated itself on the captive portal, then you can give the guy or lady whatever you like, unfiltered internet access, but the point here that you need to authenticate the client. Unfortunately, I can't give you 100% secure solution, not today and probably not tomorrow, but if you have a company and you are responsible for the network, maybe you should follow these points. Well, first of all, you should set up a set of proxy servers that have unfiltered internet access, and you should enforce those proxies over your company, like all on the computers, including workstation, laptops, and servers, including servers. That's a really important point. You should have internal DNS servers only. You shouldn't be able to resolve external DNS, external domain names. The proxy should do that. So all the servers and clients should connect to the proxy server, send a request in, and the DNS resolving and everything else should be done by the proxy server. You can use whitelisting, and you should whitelist the port 80 and port 443. That's just enough. I don't really think that any other port you could need on a proxy. And you can do blacklisting, but that's not going to help against exfiltration. Of course, there will be a list of exceptions, those servers that you can't put behind the proxy, but 99% of the servers and workstation clients can use a proxy without any problems. If you have an inventory, that's really good for you, and you should keep it updated. If you don't, you should start to do it right now. The inventory should have all of your IP addresses, the owner of the boxes, the location of the boxes, the purpose why it's there, and maybe a contact to the owner. So if you find something malicious on your network, then you can just call the guy, and he can or she can isolate it right away, like in 5 minutes or in an hour, and you won't have a breach or whatever. When you have your inventory, you can do baselining. with NetFlow and or Bro. With that, you create a statistical map of the top talkers and the IPs, the relation of the IPs, what kind of protocol they are using to communicate on what frequency and what is the volume and so on. And if you are good, if you are confident of that statistical map, you can put the stuff into alert mode. If something malicious, suspicious is going on your network, then you will get an alert. If it's a false positive, you can just add it to the statistical map and you won't be bothered again with that kind of problem. But if it's real malicious, then you can start to investigate what happened on your network. So that helps a lot. The tool was already released a month ago, maybe less. This is the web page of the tool. It's really basic and it's really easy to remember. It's XFLTReaT.info. And there is the other one, which is the GitHub repository. It's a bit harder to remember, but it's pretty straightforward as well. I want to do lots of things with this. I'm already developing it for 10 months, and I don't think it's in the best shape. It is working well and really good, at least for my purposes. But there are lots of other things that I want to implement. I want to do commenting, fixing the bugs, authentication and encryption modules, because right now it's not encrypted, which is a big thing that is missing, but I was working on the DNS for a long time, maybe too long. I want to do multi-operating system support because it's Linux only, and a few new modules that I want to implement in the next month. And this is the most important line on the slide, if you want to help, if you want to develop for the framework, please just use the next version branch. You can email me, I can answer your questions, or we can have a chat after the presentation. So thank you for your attention. I think we have 8 more minutes for questions if you have.